What's up, everybody? This is me, Yawar Manzoor, and welcome to JEE English Unacademy. Okay, and this is actually the last lecture of Kinematics 1D. Okay, so we are done with Kinematics. There will be no lectures from tomorrow onwards. Okay, and I want everybody of you to tell me, am I audible and visible properly? Yes. Okay, so in this lecture we're gonna be talking about the vertical motion. Okay, what actually vertical motion is, where does it come from, okay, what are the actual scenes, what are the questions, some of the killer questions today in this vertical motion itself. Okay, this is what we call the motion under gravity, also free fall, everything we're gonna be talking about. And before that, I want everybody of you to basically like this video as soon as possible, and all of you, and yeah, hello, and all of you subscribe to this channel, JEE English Unacademy. And this is a piece of information about me over here. You can definitely read it out from the screen itself. My name is Yawar Manzoor. I am from Kashmir and I am a JEE physics expert. Okay, yeah, good evening, good evening. Okay, chalo. So now, one second. Okay, now moving on to this slide. See, apart from this YouTube platform, we have our own platform. That's the Unacademy's platform. Okay, I want everybody of you to tell me in the live chat if everybody is doing great, nice, and absolutely fine. Okay, come on. And apart from this YouTube platform, we have our own platform. That's what we call the Unacademy's platform. Okay, over there you can take the Plus subscription and the Iconic subscription, because there are so many benefits that you're gonna get in this Plus as well as in this Iconic. In this Plus, what are the benefits you're gonna get? That is this live classes, weekly test, structured courses, unlimited access. Means in a particular category you can watch anybody's lecture. Yeah. And if you take this Iconic subscription, you'll be getting all the features you get in Plus, and there are some extra benefits as well. Like you have personal guidance, you'll be given a mentor that will help you throughout your exam, how to crack the exam. He'll be clearing all of your doubts, whatever you have. Test analysis, experts guidelines, study material, study planners. Okay, and you can definitely follow me on Unacademy. This is my username over there, Yawar Manzoor. Okay, because we are coming up with so many courses over there, that too in English language only. So I suggest you to basically join me over there. And recently we have launched this batch. This is a Spark batch. This is completely in English. This we have launched on the Plus platform. You can definitely join this one. In order to boost your rank, you should definitely go for this one. So this is particularly for the people who wanted to basically learn in English and for class 11th or JEE Mains or Advanced 2023. So these are some of the educators which will be teaching you over there. They are considered some of the top educators from different states. And this is the Shine batch for class 12th or JEE Mains and Advanced 2022. Okay, yeah. And if you want to basically join our special class, and today at 8 o'clock we will be having the special class. Okay, at 8 o'clock exactly we'll be having the special class in which we're gonna be tackling some of the beautiful problems from this motion under gravity only. Okay, I suggest you to come over there. Once we get done from this lecture, I'll be showing you some of the problems over here as well, and over there as well, some of the previous year questions as well. So chill scenes. How you can come in our special classes, that is completely for free. You just have to download the Unacademy app. You just have to log in with your number, sign up, log in with your number. Over there you have to search my name, that is Yawar Manzoor. This is my username on Unacademy. You'll find me. Afterwards, when you get this interface of my profile, you have to click on this special classes. There are so many special classes which you can watch every single time. These are the recorded one as well. Okay, you can definitely watch over there. And once you enter any of the lectures, it will ask you basically a code. That code is basically this. You have to put YAWAR in the capital letters. Okay, yeah, good evening everybody. We just have to be very furious. You can take this IIT JEE Iconic subscription. You'll be getting branded notes if you take it for 24 months, 12 months, and 18 months. By taking this Plus subscription, if you take it for 12 months, you'll be getting 2 months of extension, and this one for 2 months of extension. Now, you can definitely take this Plus subscription for 3 months, 6 months, 12 months, 18 months, and 24 months. The prices are listed over here, and the EMI options are available as well. Okay. Okay. The EMI options are available as well. So you can definitely use my code in order to get the maximum possible discount. This is my code. If you want to buy any of these subscriptions, use this code to get the maximum possible discount. Same goes for this Iconic subscription. It's for 12 months, 18 months, and 24 months. The prices are listed over here. By using my code, you can get the maximum possible discount definitely. I'm fine. What about you people? You tell me in the live chat what's going on. Okay, as we have promised you people that we'll be covering the entire chapter in just 5 lectures. That's why no side talks, just we have to go in a flow. We have to kill every damn question, every damn concept. That's why, okay? So no side talks in the class. And this is the IIT JEE Mega Combat Scholarship Test. You can definitely go for this one. You can win up to 4 crore plus scholarship. So previously it was on 22 of August. Now it will be on 29 of August, 11 a.m., 21 questions, 60 minutes. These are the benefits you can get. These are the benefits you can get definitely for this one. And if you find any of my content as inappropriate, you can definitely report in the link is in the description below. Fine. Now, today we're gonna be talking about entirely this, what we call the vertical motion. What is this vertical motion? Before understanding this vertical motion, let's have a look on what this horizontal motion is all about. Okay, till now we were dealing with the horizontal motion only previously. Okay, and this is also the case of one-dimensional motion. Okay, fine. Now see, if I ask you, this is a car, okay, this is a car, or this is whatever block car, it is moving in this direction. Understand, it's moving horizontally. Can I say this is moving horizontally? You call this as horizontal motion. Previously I have told you everything about this. We have studied this in very detail. So this is nothing but horizontal motion. Understand? Or we say this is nothing but that rectilinear translational motion. Understand? That is the case of this one. So this is what we call the horizontal motion. Now what exactly I am doing? I'm taking this block over here. I'm releasing this. When I release this block, it is falling down. So basically gravity is attracting this block towards itself. Understand? So when it is falling down, can I say this is nothing but vertical motion? Previously we were calling it horizontal motion because it was moving horizontally. Right now we are calling it nothing but the vertical motion because it is falling vertically downwards. Okay. Okay, so it is falling vertically downwards. We can definitely call it the vertical motion, or we can definitely call it that is motion under gravity. Why we can call it the motion under gravity? Because this is under gravity only. Gravity is pulling this one. Right now I am applying no force on this block. Still it is being attracted towards the center of Earth. Still it is falling down. Why? Because gravity is attracting. That's why we call it the motion under gravity. Understand? Now let's basically analyze this. We'll do the analysis of this vertical motion, then we'll move on to the problems. I'll be showing you all the cases. Whatever the questions will come from your JEE mains or advanced point of view, every damn thing will be clearing. All the special cases I have taken in this particular class, so I suggest you to watch till the end. This is gonna give you the real feel, okay? Vedat Mehra will give you the party at the end, okay? Chill scenes. Till then, we have to basically go with this. Okay. Now, this is also called the motion under gravity that I told you. Now, what is the example? Example I told you, releasing the ball over here. This is also the kind of the vertical motion. Or we throw the ball in upward direction and it is falling back. This is also the case of this, what we call the vertical motion. Now, you tell me one thing. We need to basically analyze this situation. Previously, when we were studying the horizontal motion, over there we were talking about its velocity, acceleration, how much time it's gonna take from this point to this point. So all the other stuff we were talking about over there. Now let's have a talk. Let's have a look on this one. Let's do the analysis of this stuff over there. Let's talk about its velocity. When we basically throw this ball in the upward direction, can I say that we give it the maximum velocity initially? We give it some velocity, then only it will go up. And what happens with this velocity? This velocity keeps on decreasing at the top. It becomes basically zero and then starts falling down in the opposite direction. Can we say it like that? 100%. So initially we give it some velocity. Then over here, can I say velocity becomes zero at the top? When it reaches the maximum height, then it starts falling back in the opposite direction. Can I say it starts then falling back in the opposite direction? If this is the forward direction, you can take it the backward direction. Understand? Falling down. Fine. So what happens with the velocity? Initially we give some velocity, we take that as For example, we say that is maximum. Afterwards, what is happening with the velocity? It becomes 0. Understand? At the top, it becomes 0. This keeps on reducing. Why it happens exactly? Can you tell me? Why it happens exactly? It is because gravity is pulling this one. Understand? Force is in the opposite direction. So basically, when gravity is pulling it towards itself, so velocity keeps on reducing over here. It becomes 0. That's why. Okay. So can we say this happens with the velocity over here? Understand? So now take the sign conventions that I tell you over here. When you throw the ball in upward direction, when you throw this ball in upward direction, take this velocity as positive. Consider this velocity as positive. When you release the ball, or when this ball is falling back, take the velocity as negative. You will say, why? This is just the sign convention. Okay, not a problem. Okay. Yeah, exactly. Now see, why do we basically take this? See, previously you might have seen, if the body is moving in the right direction, towards the right, in that case, we were taking the velocity as positive. If the body is moving in the left direction, we take the velocity as a negative. Why? Because this velocity tells us the direction of motion. If body is moving in the right direction, we say velocity is positive. If body is moving in the left direction, we say velocity is negative. Same is the case over. When you throw the ball in upward direction, at that point of time, velocity you take positive. When it falls back, you take velocity negative. Okay. So this was basically the analysis of velocity. Initially, it is having some velocity, and at the top, maximum height, its velocity becomes 0. When it starts falling down, its velocity again increases, Now, let me just tell you one more fact about it. Now, see, if, for example, the ball is over here, at this point, if velocity is, for example, something, I would say 10 meters per second in the upward direction, when the ball is falling down at the same point, it will have the same velocity. But if I say, for example, it is 10 meters per second in the upward direction, when it falls down, it will have the same velocity, but minus 10, because minus is what? Why? Because it is in the opposite direction. Everybody of you understanding in the live chat right now, all of you, come on. I need to know in the live chat if everybody is understanding this very clearly. Then I'll have to repeat. Fine. Then I'll move on to the next step as well. Now, we need to basically do the acceleration analysis. Okay, in this case, what is acceleration? We say acceleration in this case is nothing but that is g. Okay, why g? Because this is acceleration due to gravity, motion under gravity. We call this as acceleration as g, and this is nothing but constant. Clearly, we can say how much? 9.8 meter per second square, or meter per second. Understand? Everybody till here? Yeah. Okay. That's great. So this is constant in this case of velocity. And let me just tell you one more fact, one more thing. When the body is going upward, when the body is going in upward direction, when you are throwing the body in upward direction, and that point you take the velocity as a negative. When the body is, acceleration negative. When the body is falling back, at that point of time, you take this acceleration as negative. Understand? Because we will use this sign convention, will solve all the problems. Okay, acceleration is always towards the center of the earth, downwards. So definitely we can say this acceleration due to gravity is nothing but negative. Understand? Let's talk about the displacement. What happens with the displacement? Can we say if we throw this body in upward direction, it goes and falls back over here? Understand? So what happens with the displacement? See, it goes up and then falls back, reach the same point. Can we say the displacement? That is basically 0. And what happens with the distance? Distance is nothing but, if this is h, if this is covering h, from this point to this point, it is covering h, then falls back. So this h plus this h, this h plus this h. So distance will be nothing but, that is a 2h. Understand? Everybody? Okay. Sir, please increase the volume somewhat. Is there any problem in the volume? Not able to. You might have problem in your laptop or mobile phone. Maybe that's why you're not able to listen it properly. Check it once, Yeah. Okay. So everybody, So we say basically displacement in this case is 0. Why? Because when you throw the ball in upward direction, it falls back. So initial point is same, final point, it falls on the same point, final point is same. So displacement, it hasn't displaced, because the displacement is what? How much you have displaced from your original position. So we say displacement is 0. And what about the distance? Distance means how much it has covered, how much it has traveled. That means from this point to this point, if I say this is the h height it has covered, then it falls back again at h height. So h plus h, that is what we call the 2h. Okay, you can basically take this when you, for example, go from this height to this height, and when you reach at that point of time, you can take displacement as positive. When this ball falls from this initial point and falls on the ground, at that point you take this displacement as negative. These are just the sign conventions in order to solve the problems. Okay, rest the concepts are the same. Okay, fine. Now, as I told you, in this case we take acceleration as constant. That is what? That is nothing but g. Acceleration as constant, that is nothing but g. If acceleration is constant, can we use this equation? Can we use all of these equations? Definitely we can use all of these equations. That is v is equal to u plus at, s is equal to ut plus half of at square, v square minus u square is equal to as. Definitely, because we use these equations only in one condition I have told you previously, when acceleration is basically constant. If acceleration is constant, we can use these equations, otherwise not. What are the other equations that we can use? That is v is equal to ds by dt, a is equal to dv by dt. Understand those equations, those golden equations which I have told you previously. Okay, that's great. Okay, fine. All of you, come on in the live chat if everybody is understanding what I'm trying to say. Okay, now we need to basically derive some of the expressions. Then we will talk about some of the beautiful and special cases that will help you in solving the problems. Afterwards, we'll move on some previous year questions. This is the topic today's. Okay, this is the goal, today's goal. Now listen to me very carefully. If I say I'm throwing this ball in the upward direction, okay, and it is coming, this is basically the path of this ball. So can I say that if I ask you to tell me how much is the maximum height attained by this body, if I say, for example, I'm throwing this ball with a velocity u in the upward direction, it will go till here. For example, if it reaches this height, so how much is this height? Can you calculate this? We need to find the expression for that. Now, if I ask you how much is the time taken to complete this vertical motion, okay? So can you find that time to complete this entire motion? How much time it's gonna take from this point to this point in falling back completely? We need to find the expression of that. How much a displacement it is gonna cover, how much a distance it is gonna cover, that I told you previously. We'll find the expression for that. Velocity with which it returns back. If we throw it with some velocity, and when it comes back, what will be the velocity exactly when we were launching it? These are the questions that we need to basically answer in this one. So this is exactly our goal. Fine. Okay. Now, first of all, we need to go with this one. That is this time taken to complete this vertical motion. If I'm throwing this box, if I'm throwing this ball in the upward direction, how much time it's gonna take? So this will be basically its motion, and it will fall back. How much time it's gonna take? Can I say over here, when this block goes from this point to this point, from zero, this point to this point, I would say it is taking, for example, time t1. When it's falling back, I would say it's taking time t2. This t1 plus t2, time t1 is what? We call it the time of ascent. Okay, how much time it's gonna take from this bottom till height, maximum height. And this t2 is nothing but time of descent. Understand? And if I ask you to tell me the total time of this motion throughout, you will simply say that is nothing but t is equal to t1 plus t2. Very easy. Okay, now how we are supposed to find this t1, this t2, and put it over here? We'll get the total time of this entire motion. Everybody is able to understand this one? Come on in the live chat as soon as possible, man. Okay, okay, now let me just find this time t1. See, I'll first find this time t1. See, the time it will take from this point to this point, same time it will take from this point to this point when it's falling back. So I'll find this time t1 only, multiply that by 2, I'll get the total time. or I'll show you the another method as well. I'll show you the another method as well. Don't worry about that. Okay, so how do we find this time t1? We can use those formulas because acceleration is constant over here. We can use those formulas from this point to this point exactly. Which one? V is equal to u plus at. Use this. V is equal to u plus at. Understand? Now, if I'm using the formula, if I'm using this equation from this point to this point, what is the initial velocity? That is u. For example, I'm giving it the u velocity. And what is the final velocity? As I told you previously, over here velocity becomes 0. Final velocity becomes 0. So initial velocity is having some value, final becomes 0. So can I say this is nothing but this is u? And I told you how much is the acceleration? We take acceleration as negative. Even if the ball is going in upward direction or the ball is falling back, in both the cases we take acceleration as a negative. Can we say instead of this a, I can write this g, acceleration due to gravity 10 meter per second square, 9.8 meter per second square. Fine. And this time, I'll just write a time t1. This is what we are supposed to find over here. Can I write this? This time t1 is nothing but I'll take it over there. This will be u by g. Clearly, everybody. Now, as I told you, this time t1, as I told you, this time t1 is equal to t2. So simply I can just write over here, this time will be nothing but u by g plus u by g. That will be nothing but 2u by g. So how much amount of time it's gonna take throughout this motion? That is 2u by g. So it depends upon, time depends upon completely velocity. The more velocity you give it, the more time it will take. Why will it take more time? Because if you give it more velocity, it will attain more height. So it will definitely take more time. Now if you give it some less velocity, only less, understand? In that case, it will reach this height only and will fall back. So time will be also less. Okay, fine. Let's move on to the next one. Directly, if I ask you to use this equation directly and you tell me how much exactly is the time over here, can you guys tell me? Can you guys tell me without using that method? See, without over here, I'm saying that t1 is t2. Without that, directly if I ask you to use this one, okay, directly if I ask you to use this one from this point to this point, how much time it is gonna take from there to there? You will say simply we can use this equation. Use this equation directly, we'll get the answer. See over here, how much is the displacement? Ball is going up and it's falling back. Understand? So displacement is basically 0. Why is displacement 0? If the ball is going up and again back in this initial point and final point are same, obviously the displacement is, in that case is 0. Can I say this is 0 over here? 100% over here 0. And what is the initial velocity? That is nothing but u. And this t, how much time it is taking from here to here exactly? That is nothing but this t. And minus, can I just write 1 by 2? And instead of this acceleration, I wrote minus g. That's why minus over here. That's minus g. And this is nothing but t square exactly. Okay. Everybody is able to understand this one. Come on in the live chat right now. What's up, buddy? Come on. Now, so take it over there. I can definitely write this is your gt square by 2 is nothing but ut over here. Any problem? So this will get cancelled off. T is nothing but that is 2u by g. Direct with the one single formula. Okay. So how much time it's gonna take from this point to this point? That is 2u by g. Why? Because initial displacement is obviously 0 because it is reaching back to its original position. That's why. Okay. Let's move on to the next one. If I ask you to tell me how much height it is gonna attain, if you give the velocity u to it, how much height it is gonna attain, how much high it's gonna go, this much, this much, this much. Exactly. Can you find direct expression for that? Can you tell me how do we exactly do that? That we need to find in this one case. So use this formula directly from this point to this point. Understand? We need to find basically this h height if we give u velocity to it. That's all. Okay. Use this formula. Can I say how much? We need to find this h. This is the maximum height attained. Can I say this is h? Understand? Instead of this, because this will be when it goes from this point to this point, it will attain the height h. This is height h exactly. So this is nothing but initial velocity that I'm giving it. That is nothing but ut exactly. And this is nothing but plus 1 by 2. And this will be, instead of this, I'll directly write it minus 1 by 2. Acceleration, that will nothing be g. Why g? Acceleration due to gravity exactly. So this is g and this will be nothing but that is a t square. previously we got the value of time, how much time it is taking from this point to this point, from this point to this point. That was a t1. That is u by g. U by g. Can you put that u by g over here? So this h will be nothing but, this will be nothing but, this will be u into, this will be u by g and minus 1 by 2g, and u by g, it will be u square by g square, exactly, because instead of this t, I'm putting this one. Why am I putting u by g only? Because we have to find the maximum height from this point to this point only. So this interval, put the time value for this interval only, that is u by g, that is u by g, exactly. So can I just write exactly over here, this h will be nothing but, it will be u square by g minus, and this will get cancelled off. So it will be nothing but 1 by 2 u square by g. See, in full, 1 minus half, 1 minus half. This is u square by g minus half of u square by g. Full minus half. What we're gonna get? Obviously half. So that is nothing but h is equal to, that is 1 by 2. Full minus half is nothing but half u square by g. So exactly what we're gonna get, I'll just write h is nothing but u square by 2g. Come on. Yeah, exactly. That's very nice. Very good. Sai Ganesh. Siva Ganesh. That's great. Now, we do basically want to use this long method. Just we'll do it in with one single method. Can I use directly this formula? From this point to that point, final velocity, when the body is going from this point to this point, in that case, can I say final velocity is basically 0, initial velocity is basically u something, finally it becomes 0 at this point. So it will be 0 square minus u square is equal to minus 2gh directly. Why minus 2gh? Because acceleration is minus g, we take it minus. So now in that case, can I basically get this, what we are supposed to find, h is nothing but, that is u square by 2g directly. In this case, minus will get cancelled off. Everybody, come on. I need to know in the live chat if everybody is understanding this very clearly. Come on, everybody of you, live as soon as possible. Now, with what velocity it will return exactly? With what velocity it will return exactly? Okay, I'm saying that, for example, I'm launching this with a velocity of u. Okay, it is going up, 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 up. Over here, velocity v becomes 0, and finally it is coming back. For example, if I ask you over at this point, the velocity of this ball is what, u. When it is falling back exactly at this point, how much will be its velocity? Okay, I told you previously it will be exactly this u, but in the opposite direction. But it will be minus. It will be yes. Yeah, that's great. Okay, now come on. Use this formula directly. From where to where? From this height to this bottom. From top to bottom. From top to bottom. Because we need to find the return velocity. Means we can use the equation from this point to this point. Understand? So that's why I'm saying at this point, initially we can basically put this velocity as initial velocity u. Why? Because we are using the formula from this point to this point. So initially we can use this velocity as initial velocity, that is 0, because at the maximum height, when it starts falling back at maximum height, velocity is basically 0. Velocity is 0. Understand? When it starts falling back, velocity starts increasing. At this point, it will be again maximum velocity with which we have launched it. You will get to understand how exactly. Can I just write this equation, v square minus u square is equal to as? What is the final velocity at this point? From this interval to this interval, that's what we are supposed to find. That is v square minus, what is initial velocity? From this point to this point, I am saying initial velocity is 0 because at the top is 0. So I can write 0 square is nothing but, is equal, this is nothing but 2, and this will be minus g, and this will be what, h. Why minus g? Acceleration is minus g. And why h? Because I'm saying that this height is basically h over here, that's why. Okay, that's great. Can I just write over here, this v square is nothing but, this will be 2gh, and this will be negative. Clear over here? Come on, all of you. Can you tell me in the live chat over here, how am I supposed to get exactly that value? Come on, all of you. It can't be 0. How can it be 0, Kushi? Now, you tell me one thing. Can I just write this v square is nothing but 2g instead of this h? How much height is this? We have previously we previously got this. How much is this height, maximum height attained? That is u square by 2g exactly. Understand? So this 2g will get cancelled off. V will come out. This is square. So V will come out to be nothing but u, but in negative direction. That's why I told you, if we are launching this with a velocity u, finally it will come back with a velocity of v is equal to minus u. Same velocity, magnitude will be same, but the direction will be different. That's why I told you, if you are taking this, okay, u is 0, that's fine. If you are taking this velocity as positive, when it comes back, you take this velocity as negative. So that's why v is a minus u, means velocity, magnitude of velocity will be same, just the direction will be opposite. Fine. Okay, let's move on to the next one. Displacement traveled. How much is the displacement traveled? How much is the displacement traveled? Understand? If this ball goes from this point and it reaches back to this point, how much will be the displacement traveled over here? Okay, come on. Directly you can use this formula. Okay, how much displacement is basically traveled over here? Come on, can you use this formula? From this point to this point, we are launching it with a velocity u, initial velocity u. Now, can you tell me this displacement we are supposed to find? It has to be 0 because it is coming back exactly. I'll prove this. Why? How exactly it will be 0? Can I just write s is nothing but initial velocity? What is that? That is u. And how much time it is taking from this point to this point? T. Previously, we got that how much that is 2u by g. Total time taken from this point to this point in completion of this journey. How much that is? 2u by g. So can you put that over here? That will be, instead of this t, I can definitely put 2u by g, and this will be minus 1 by 2. Why minus? Because acceleration will be minus g, and this will be g, and instead of this will be 2u square. So I'll just write it directly. 2u, instead of this is 2t square. So it will be 2u square, that is 4u square. 2u whole square. 4u square upon g square. So this will get cancelled, 2 1s, 2 2s. So s will be nothing but this is 2u square by g minus this will be how much? 2u square by g. 2u square by g into 2u square by g, it will come out to be 0. So displacement is basically 0. That's why I told you, okay? Using the conditions, definitely it will be 0. Now, how much will be the displacement traveled? Sorry, distance traveled. Distance traveled is simply, if it goes up, it has covered this much of distance, that is h. When it comes down, again h. So I can say that is definitely 2h. And what was the value of h? What was the value of h? U square by 2g. So can I just write it? This is nothing but u square by 2g. Understand? This and this will get cancelled off. So it will be nothing but u square by g over here. That's great. Let's move on to the next one. Now is the special case, okay? I want everybody of you, till here it was easy, but now also it is easy, but from the competition point of view, this is bit important. So I want you people to listen to this very carefully from the that's why I have basically given it the special case. Next one is special case 2, special case 3. Okay, I'll be explaining all the 3 special cases over here, what it exactly will be. So first of all, this is a falling body. This is not that special, but still I'm saying this is a special. Okay, first of all, this is a falling block, falling body or free fall. If I'm releasing this block over here, no extra velocity given, just releasing, it will fall under gravity, it will come back. So first of all, what I'm supposed to find is time taken to reach the ground. How much time it's gonna take to reach the ground from this point to this point, how much time it's gonna take, I need to find that exactly. Okay, that's my first goal over here, time taken. Okay, can you guys tell me in the live chat how you can exactly do it? Come on, all of you. I'm waiting for you people to answer me. It's a falling body. Now you tell me one thing. When it is basically falling and it reached this point, I told you at that point of time, how much is basically the displacement traveled? This is kind of negative displacement. It is similar like, for example, this is the origin, okay? And if you travel from this origin to this point, this is your initial point, this is final point. If you travel in the negative direction, at that point of time, we take displacement as a negative, okay? Don't say if you are traveling in the negative direction, that means your displacement. No, if you are sitting for example, at s is equal to -10 in the rightwards of origin, at that time we are taking the displacement as negative. Same is the case over here. What is the initial point? That is the top. What is the initial point? This is the top, and it has fallen back. So when it is here, it has covered the negative displacement. We say this is the initial point or this is the origin. Okay, fine. So can I say how much a displacement it has then covered from this point to this point? I would say this h, height h. So can I just put it over minus h because it has reached this one, so it will be negative of h. Initial velocity, when we are releasing this block, initially how much? 0, because as I told you previously, at this top velocity is basically 0. So clearly initial velocity is 0, so it will be u into t, 0 into t. And over here it will be nothing but negative. It will be negative of 1 by 2, and instead of this acceleration, what it will be exactly? That is g, minus g. That's why minus is over here, and this is nothing but over here. I can definitely say this is nothing but a t square. Okay, come on, all of you. Now we need to find the value of t. Can you find it? Definitely. So it will be nothing but, so t will be nothing but, that is a 2h, this h by g, it's a root. Why? Because see, 2 multiplied by this h, minus will get cancelled off. 2 multiplied by this is 2h upon g, and this square will basically make a root over here. So this is the time taken from this point to this point if the body is basically releasing, if the body is falling, if the body is basically falling. Now, what is the velocity of hit? Means at this point, when it is about to hit, how much will be its velocity? How much will be its velocity? That we need to exactly find over here. Can you tell me what will be the value of that one over here? Come on. Can you tell me in that case? User, definitely simply use this formula, that's all. Okay, so can I say final velocity? That's what we are supposed to find at this point when it is hitting about this point. So we need to use the equation from this point to this point, from this point to this point, initial point, final point. So now finally we need to find that velocity. Initial velocity, I told you, that is 0 because body is, we are releasing the body. Initially its velocity is 0, and this will be nothing but acceleration minus g, and instead of this t, it will be how much? How much time it is taking from that point to this point? That is root of 2gh by g. That is root of 2h by g, 2h by g. Root of 2h by g, 2h by g exactly. Okay. Now let's do some of the simplifications over here. So it will be minus g, root of 2h by g multiplied by, do the rationalization. Okay. So this will be root g and g. So it will be nothing but, this is minus g, and it will be 2h exactly, and multiplied by this root g, and over here root g into this root g, it will be nothing but root g whole square. Square and root will get cancelled off. It will be nothing but g only. This will get cancelled. So we can definitely write v is equal to negative of 2gh. Okay, so what is the value of velocity of hit? That is negative of, sir, color is not clear. Which color? This color is not clear. Shall I write with the white one? Is this clear? Okay. Okay. 1 second. I need to check the size of the PPT. One second. 44:24. It's okay. Still, I will make it like. Chalo, it's okay. It's okay. It'll create the confusion then. Okay. Yeah. Okay. Now you can basically find this velocity of hit. Why is negative over there? Negative is because. Okay, fine. So negative is because it is falling down. Understand, it is in the negative direction. Velocity of hit means when the block exactly is about it, at that point, how much is the velocity that we calculated? How much is that? Minus root of 2gh, minus a root of 2gh, minus a root of 2gh exactly. Fine. Now let's move on to this one. Or you can directly use this equation also. V square minus u square is equal to 2a h, 2ah, 2as instead of s, you can write this h. So v square you need to find, it will be nothing but minus 2gh, okay, and take this root over here, you will exactly get this equation. Fine. Now special case 2, let's move on to the special case 2. This one, this is the special case 2. Yeah, so what is the special case 2? If I ask you, see, this is one of the beautiful cases. I want you people to listen to this very carefully. I am launching this ball in the upward direction, okay? If I say that I'm launching this ball in the upward direction, okay? If I say that this is creating, this is basically going till h max. This is the highest. This is the highest. What do we say this? Maximum height attained by this one. If we are launching this velocity of, for example, I would say u. In that case, if I ask you how much time it is gonna take to reach the half of the maximum height, means h naught, h max by 2, I would say h max by 2. How much time it's gonna take from this point to this point? If this is the maximum height attained by this ball, I'm throwing this ball in the upward direction. If this is the maximum height, I'm saying that for a maximum height, we already calculated the time, okay? Forget about that. Now, if I ask you, how much was that? U by G, okay? Now, if I ask you how much time it's gonna take to reach half of the maximum height till here only, how much time will be that? Time to reach the half of the maximum height, okay? How can we exactly find that? Now, listen to me, we'll use this formula directly and we'll get the answer of this one, understand? Now, instead of this S, previously, when it has covered the maximum height till here, now, in this case, we'll use the equation from this point to this point only. Understand? So, till here, how much it will be? This is h by 2. Instead of this s, I will write definitely that is this h by 2. H by 2. So, I'll write this h by 2 over here. And it will be nothing but, instead of this u, how much is this velocity, initial velocity? In this case, I'm saying that this is nothing but ut plus 1 by 2. Why? Over here, I'll just directly write this is minus 1 by 2, because why? Acceleration is minus g. So this is g and this will be nothing but a t square. Okay, all of you, this is a very beautiful question. It will definitely help you to basically wash your mind, clean your mind. Now see, can we just write this is h by 2 over here? This will be nothing but multiply this with this 2ut. It will be minus of a gt square upon this 2. Okay, I can definitely write it will be nothing but take it over there. So this 2 will get cancelled off. So gt square, I'll just write at is it. I'm taking this gt square over here, this also over here. So 2ut and this minus plus h is over there. It will become exactly 0. So we got this quadratic equation. Now what we are supposed to find? We'll get the roots of this quadratic equation in terms of, this is in terms of t. Now let's find that. So can I say t is nothing but minus b, that is this 2u plus minus under root b square. You know how to find the roots of a quadratic equation. You might have seen this in your 8th class. B square, that is nothing but this 2u square, that is 4u square, okay? Minus 4ac. What is a? That is this g. What is c? That is this h exactly. Fine. Upon this 2 into a, that is 2 into g exactly. We'll just write it over here. So we got this one. Let's do some of the simplifications over here. Yeah. Okay. Fine. Now let's move on to this one. So let's do some of the simplifications. I'll just write t is equal to 2u. This is 2u plus minus, and this is root of 4u square minus 4g, and instead of this h, I will put the maximum height attained exactly. I would put the, yeah, it's very difficult to decode over there in the live chat. I'll just find it and then accordingly. Okay, instead of this h, what is the maximum height attained from this point to this point? Because this is h by 2 only. This height is over here maximum height. We have previously basically found this. We got this previously. That is nothing but u square by 2g. That is nothing but u square by 2g exactly. Okay, everybody. And over here it will be nothing but 2g. So t is equal to, before I solve this, I want you people to solve this. Can I just write over here, this is 2u plus minus exactly. So this is what? u square by 2g, so this will get cancelled off 2 and this will get cancelled off this one, so it will become 2u square. So 4u square minus 2u square, how much that will be? This will be 2u square only, so root of 2u square only upon this 2g I can write. Okay, what else can I do it over here now? So t will be nothing but this is the 2u plus minus this u will come out basically, and it will be root 2 upon this 2g. So finally I can just write, take this u common, it will be 2 plus minus this root 2 upon this 2g exactly. So we got this total time, how much time it is gonna take, to travel this distance and comes back. Okay, this is the total time. Now if I ask you to tell me what is the time of ascent, that is a t1 from this point to this point, and what is the time of descent from this point to this point, clearly we can find this one only. Okay, so can I just write, if this is the total time t1, I can write how much, that is, you take this one u, this is time of ascent when body is going up till this maximum, half of the maximum height till there, so this will be u into 2 minus root of 2 upon 2g. Okay, and this t we will take the another one, t2 will be nothing but u multiplied by 2 plus root of 2 upon 2g. See, why am I taking this plus and negative over here? When the body is going in the upward direction, at that point of time velocity keeps on decreasing, something will be reduced, u into 2 minus something will be reduced to that, understand? Over here it will get added. When the body is falling back, at that point of time velocity increases from 0 and it keeps on increasing, that's why over here. Okay, everybody, so that's why I'm taking the negative over here, positive over here. Time of ascent and time of ascent, I'm taking this negative, and time of descent, I'm taking this positive. Come on. I hope this is clear to everybody. Now this is the special case 3. Let's move on to the special case 3. Okay. This is basically, these are the questions itself. Okay. These are not the special, these are the questions itself. I have just mentioned the special cases. Come on. How much is it? 6:47 already. Okay. Now, let's go from this point to basically this point. Understand? What time to reach any general height. Now, if I ask you to tell me how much time it's gonna take till any general height, we are basically throwing this body in the upward direction. If I say, for example, it goes till this height only, we don't know how much is this, we say h height, how much time it's gonna take till this general height, not the h max, because till h max we already calculated, till half of the h max we already calculated. Now I'm saying that till any general height, from this point to this point, from this point to this point, from this point to this point, calculate the expression for that one. Okay, come on. Let's go for this one. Use this formula once again and you will get to understand that. So can I definitely use, I would say, for example, it is going till height h. So I'll just write it over here h. This is ut minus 1 by 2 and it will be gt square exactly. Understand? For example, it is taking time t till this general height. Now can you solve this one? I would write this h is nothing but u2. This multiply with this one 2ut. This will be minus gt square upon this 2. Now take it over there. So it will be nothing but 2. I'll directly take it over there. This will be 2h. Okay. Can I just take it over there right now? Yeah, this will be gt square minus 2ut plus this 2h. It will be equals to 0. Come on. How many of you understood this one over here? So again, we need to find the roots. We'll find the time of ascent, time of descent, and total time as well. Now, can you find the roots over here? Simply, that is a t is equal to minus b, that is a 2u. Already it's minus. Plus minus under root d. What is a d? That's b square. That is 4u square. Minus 4a, that is g. And c, that is multiplied by 2h exactly. I'll just write as it is. So it will be nothing but, and 2a, that is a 2g exactly. Fine. Now we'll have t1 and t2 over here. Let's find the t1 and t2. Okay. See, you will see, sir, can we put the value of this h over here? How much that will be? Can you put the value of h max over here? No, you cannot put the value of h max over here. Okay. because this is still general height, any general height. Now put this one, take it over there. Okay, there is the question, another question. So I just have to find the T1 and T2 in this case right now. So first of all, you take this 4 as common and then take it out. When we take the 4 from this one, root of 4 is nothing but 2, so we can definitely take it out. So it will be nothing but T is equal to, that is 2u plus minus. So it will be, when we take this out, so it will be 2, and it will be nothing but this u square minus, it will be nothing but 2gh exactly, and over here it will be nothing but 2g. So we can definitely take this 2 again common and cancel with this 2, this 2, this 2. Finally, what we're gonna get over here is, I'll just write it over here. Okay, so this is, okay, I'll just write it over here. So can I just write, this will be nothing but, finally, I'll just erase this one. So this T is nothing but, it will be what? U, arey yaar, idhar jagah hi nahi hai. There is no space over here. Okay, I'll just mention it over here. Where exactly? Okay, just exactly over here. So I'll just write T is nothing but, T is equal to nothing but, that is this U, that is this U only, this U plus minus, and that will be nothing but a root of u square minus 2gh. Am I doing it correctly? Check my mathematics. Okay, so this is nothing but a g. Okay, everybody, come on, in the live chat, I need to know if I'm doing it correctly. Okay, all of you. Yeah. Now can I just write the T1 in this case? Now what will be T1? That is u minus this, that is u minus this root of u square minus 2gh upon this g. Why minus? Because when you throw the ball in upward direction, in that case velocity will be reduced. Understand? That is u initial velocity minus something, that's why. And when we take the positive, just I'll write the T2 over here. T2 will be nothing but, that is what, when the body is falling back from that height, so can I just write, that is u plus, this u plus, that is root of u square minus 2gh upon that g exactly. So this is time of ascent, this is time of descent, and this is exactly the total time. This is the total time. Yeah. Okay, let's move on to the next one. Okay, now we have this question. This was asked in JEE Means 2004. Can you solve this question? A, B, C, D. It is saying that a ball is released from the top of a tower of height h meters. It takes t seconds to reach the ground. Okay, this ball is released from the top of the tower, this having the height of this h. It takes, for example, t seconds to reach the ground. You need to tell me, when the time is basically what, t by 3 seconds, what is the position of the ball? For example, if I say over here, this is t by 3 seconds, what is the position of the ball from the ground? Come on, tell me. A, B, C, D. Come on, mark the options in the live chat itself. A, B, C, D. Which option is correct over here? Come on. Let me just solve it before you do it, because I have no expectations. Come on. So let's use the equation first. In the first case, when the ball is released from this height to this height, understand, initially it is saying that it is covering this height in time t seconds. Okay, let's use the equation in first case. For first case, when h height is covered in t seconds, okay, or t time, what is it, t seconds, okay. So use the equation. So s is equal to ut plus 1 by 2 a t square, okay. We can use this equation. A become 2, where exactly? This is 4, see, this is 4 a and c. C is what? This. See, this is in quadratic equation in terms of this t. So this is the what do we say? अरे वेरिएबल के सामने क्या होता है यार, नाम भूल गया मैं उसका. This whatever it is. So this over here, okay, this is the constant term, okay. 4a, okay, instead of before this t it is this g, okay. So this g, 4a and c, what is this? This will be this. So then we took this 4 as common in this one. We took this 4 out. Root 4 is nothing but that is 2. That's why I wrote this 2. It will be u square minus over here this 2gh exactly. Understand? So that's why we did the simplification. Okay. Come on, now let's move on to this one. Yeah, coefficient, exactly. Sometimes I forget the spelling of the. Is it THA or is it THE? This happens, okay? Yeah, 4 into 2. What are you saying, Khushi? From this point to this point, we'll use the equation, okay? We'll use the same equation from that point. So can I say basically this is nothing but this is h. H height is covered initially. What is the initial velocity? We're releasing this ball. Initial velocity is what? That is 0 because they're releasing. So covering this height h. So it will be nothing but 1 by 2 gt square exactly. So we got this height. So we basically found this height, how much exactly this height is, that is covering, that is being covered in time t. That is being covered in time t. Definitely go for this one. Kidhar gaya? Yeah, now it is saying that, for example, when it is taking t by 3 seconds, when the time is t by 3 seconds, at that point of time, this is nothing but h dash. So can I use the same formula for the case second? For when time is t by 3. In that case, can I use this s is equal to ut plus 1 by 2 at square? Clearly, we can definitely use this one. So how much is this h? I would call this as h dash, and ut, initial velocity when we are releasing this, it is basically 0. So this will be nothing but we take it at negative. It will be 1 by 2 g, and this is t by 3 whole square. Because time is t by 3 when it has covered this h dash distance. What is this gt square? What is this? We are supposed to find this h dash. What is the height of this height? Sorry. I made a silly mistake over here, okay? So this height is basically, this is not this height, okay? This height is from the ground itself, okay? This height is from the ground itself. When you say, for example, the particle is falling, it has fallen from this point to this point. In that case, you check how much it is above the ground, okay? In that case. So over here, we are also checking how much it is above the ground from this one, in that case, okay? So now, in that case, can we just write this h dash is nothing but this is 1 by 2 gt square. How much that was? That was 1 by 2 gt square, this previous h. So I can just write h into this 1 by 9. So it will be nothing but h by 9 meters from the ground. Okay, understood? So which option? Option number C. Okay. Come on, let's move on to the next question. This is a very good question. I want you to solve this at your own. Can you do it? Can you do it? Come on. Can you just do it? Come on, all of you in the live chat. Now see, two balls are released from a height of t is equal to 0, from a height at t is equal to 0. And another ball is released at t is equal to t naught after some time. So the two balls over here, basically I have made this over like this, okay, so that you'll get to understand this one. So initially the first ball is released at t is equal to 0. We released this ball, okay, it is falling down, falling down, falling down. Now after some time, t is equal to t naught, we released the another ball, but we gave it some velocity, initial velocity. His initial velocity, the ball, this ball will have the initial velocity, that is 0. We released this ball. Everybody is doing the silly mistake. This is a silly day. Okay, now, so this is having no initial velocity. This is having the initial velocity of v naught. This is having the initial velocity of v naught. We gave it some initial velocity. It is saying that at some point, find the time at which the first ball will hit second ball. We have to find what will be the value of that time when this ball will hit this ball. This is an advanced level question. Can you solve this? Okay, if I say, for example, when we release this ball, it reached over here. After some time, when we release this ball and we gave it some extra velocity, it will reach over here. It will hit. Basically, it will be something like this. First ball we released, it will reach here. Second ball, after some time, it will again reach here or will hit this ball. Okay. Oh, this is the last session. Okay, after this, we'll have one shot of kinematics the day after tomorrow. I want everybody of you to join that. We'll be killing the entire kinematics in one shot, and there will be detailed analysis as well, and the problems will be the next level problems. Okay, the people who have missed the previous lectures, they can join us in the one shot of kinematics 1D, day after tomorrow. Okay, fine. So what I'm saying that now you will say, you will have question in your mind, sir, how is this ball supposed to hit this ball if we release this ball initially and after some time we release this ball? This is a very common sense, very common question. Okay, see, if this ball, the second ball, we are giving it some initial velocity. That's why this is having more velocity. So this ball will cover the same distance in less amount of time because it's having more velocity. This ball will cover the same distance in more amount of time. So eventually they will meet at a point and they will hit each other. Okay, we'll basically next we'll start with the projectile motion. Come on. So can I just say from this point to this point, from this point to this point, from this point to this point, if I say this ball has covered how much of distance, I would say y1 of distance. How much of time? I would say in t naught of time. Okay, this ball has covered the distance of in t naught of time. At any general time they are basically meeting. So this ball has covered y1 of distance from this point to this point in t naught of time. How much this ball will cover? I would say, for example, y2 in how much amount of time? That is general time minus this t naught. So that is t minus this t naught in t minus t naught amount of time, because this is released initially. After some time we release this ball, understand? So we release this initially, this is taking t naught of time. This ball will have some initial velocity, so it will take less time to cover the same distance, then only it will basically hit. So that's why I'm saying this will be that general time that we are supposed to find, that t minus t naught. Okay, you understood this? Come on. If I say this is taking y1 in covering this much of time distance, this is y2, can I say if they are meeting at this point, point A, then y1 has to be equal to y2, because they are meeting now, they are hitting each other, colliding. Okay, that's why I'm saying y1 is equal to y2. Now the approach over here that we're gonna be using is, you find the y1 of this ball, you find the y1 of this, y2 of this ball, you equate both of these and you get the value of time. That is the approach in this question. This is an advanced level question. Over here you will have to use more concepts. Okay. Now let's find y1. Y1 is for first ball. I'll write for first ball, and over here this is for second ball. Okay, can I find the y1? Y1 is nothing but, what is y1? Y1 is nothing but this distance. Now how can we cover this distance? How can we find this distance? S is equal to ut plus half of at square. S is equal to ut plus half of at square. We can use this one. So definitely, so instead of this S, I am writing from this point to this point as y1. So can I just write this y1 is equal to, that is ut. Initially it is just released, no extra velocity given, so it will be nothing but 0 into t, ut 0 into t minus 1 by 2, and acceleration is what? That is a g, and this is what? T is what? That is a t naught square, 100%. And we take this as a negative also, this in this, because this has covered from this point to this point distance. So it will be y1 will come out to be nothing but it is 1 by 2, and it will be g t naught square. Any sort of confusion till here? Okay, fine. Now for the second ball, we need to basically use the same equation for the second ball as well. For this one, use the same equation. Can I use this one? This is y2 is nothing but initial velocity. We are giving it some initial velocity, that is v naught of time is what? It is taking how much amount of time from this point to this point? T minus t naught, t minus t naught minus, you take this as minus in negative direction, minus this will be 1 by 2 g, and this will be t minus t naught whole square, this is t naught. Everybody is able to see this one. Let me just show you. Yeah, you can see this one. So can I just do one thing? So I'll just basically convert it to the plus. So I'll just write y2 is nothing but, take it over here. Basically we have to take minus common, and then we'll cancel it with this one. So it will be 1 by 2 g of t minus t naught square, and this will be minus v of t minus t naught exactly. There will be a big quadratic equation that I want you people to solve, but you by yourself. 8h by 9. Chalo. So can I just now y1 is equal to y2, because this ball is basically hitting this ball. Obviously they will have to cover the same displacement. Y1 is y2. Now we equate these two equations. We can definitely write on this one. So 1 by 2, it will be nothing but 1 by 2 g t naught square is nothing but 1 by 2 g t minus t naught, 1 by 2 g of t minus t naught whole square, then this minus v naught into t minus t naught, v naught into t minus t naught. This will be a big quadratic equation. So this will be g t naught square by 2 is equal to nothing but, multiply it over here. So this will be g of t minus t naught exactly minus 2 v naught of t minus t naught exactly by 2. This 2 will get cancelled. So over there finally we'll get this quadratic equation. I want in terms of t. I want you people to basically solve this. Okay. Okay. I want you people to solve this. Okay. I want you people to solve this. Okay. And I want you people to solve this and tell me what is basically the exact answer. What is the exact answer? Because this is the quadratic equation that you are supposed to solve by yourself. So exactly what is the time? You will be, it will be in terms of time. So it has to be basically something like v naught minus g t naught by 2 upon v naught minus g t naught multiplied by this t naught. This has to be the value of this t. You need to solve this one and you will get the value of this one. Okay, fine. Come on, let's move on to the next one. Come on. Okay, let's solve this one. Let's go with this. So this is the another question, masterpiece, advanced level question on the same concept, okay? I want you people to basically solve this. I want you people to solve this at your own. No, I'll show you, okay? It will create a confusion in you. There has to be, here we need to basically use some of the beautiful concepts. It will be fine. It will be nice, okay? It will be nice. And listen to me very carefully. Listen to me very carefully. Okay? Now, have a look over here. Now see, what is the situation saying? A balloon is going up with an acceleration A at time t is equal to t naught, okay? At time t is equal to t naught, it actually started. It started going up from the rest. Okay, it's saying that at time It has to be here is this. At time t naught, it has started going up, started from rest. At time t naught, it released a package. See what it is saying exactly. Let me just make you understand. So this is the balloon, okay? This balloon is basically started going up, means initially its velocity is basically this u is 0. Initially its velocity is 0. Started from rest, going in upward direction. Fine. At t is equal to t naught, when for example this reached over here, this is the balloon, it reached somewhere around here, okay? So at t is equal to t naught, it released a package. Okay, it is going up with an acceleration a that is given, okay? So at t is equal to t naught, it released a package over here. This is the package, okay? This is the package at t is equal to t naught, and it's going with the acceleration up. You understood the concept, what I am trying to say, okay? Now see, when this balloon started going up, initially it was at rest at t is equal to 0 seconds, going up with the acceleration a. When time is t is equal to t naught, for example, the balloon reached here. At that time, it released a package. We need to find how much time this package is gonna take to reach ground. This time we need to find in this one. This is a very beautiful question. You need to basically listen to this very carefully, and I want everybody of you to answer me this question before I solve this. This is a very nice question, okay? Okay. It will, this is the last question, okay? Once we get done with this, afterwards. Okay, fine. Now see, listen to me very carefully. What I'll do, see here also we'll use the same concept, that y1 is equal to y2, Now we'll use for balloon as well as package. Now let's go for the balloon first. For balloon, okay, you tell me one thing. When this balloon released this package, at that point of time, what was the height of this balloon? Can I say the height of this balloon was this y1, and what was the height of this one? It was, for example, I would say y2. Is y2 equal to y1? 100%, because when this is about to release this package, at that point of time, can I say this y1 will be equal to this y2? 100%, 110%, okay? Because at that point only, when it is not released yet, about to release, so I would say y1 will be equal to y2. Now use the equation this, s is equal to ut plus half of at square, okay? In this case, use this one, use this for finding this y1. I would say this y1 is what? The height of this balloon, how much it will be exactly? Can you guys tell me in the live chat? Every single time I take the nice questions, it completely depends upon the topic, okay? If there are questions in the particular topic which are nice, then I'll have to take that. On a particular chapter, there may be so many number of questions which are nice according to you, but on a particular topic, it keeps on changing. Okay, now you tell me one thing. Can I find this y1 over here? You tell me. See, initially it is saying that when we we are talking about this balloon at this point of time, what will be exactly? Can I say this y1? How to find this y1? Initial velocity, that is what? 0, exactly, initial velocity. And can we say this ut plus half of at square? So this will be 0t plus, instead of this plus, I'll definitely write this minus. So this will be nothing but minus 1 by 2, and it will be what? G, and I would just write it nothing but what? How much? Can I just write t naught or t? Definitely it will be t naught of square, okay? So y1 it will be negative, so negative will cancel, so it will be nothing but 1 by 2 g t naught of square. So this equation is for the balloon. For example, this is the amount of time the balloon is basically taking. Everybody understood this one? Okay, fine. Now let's go for basically the package. Let's go for the package. For package, exactly. Now for package, if we use the same equation, but we don't know the initial velocity, you will say, sir, what is the initial velocity of this package? See, initial velocity of balloon was 0. It started from rest, okay? But initial velocity of this package is what? Initial velocity of this package, we are talking about the package from this point to this point, okay? You getting me what I'm trying to say? Everybody is clear with this one. So initial velocity of this package will have something, because in that case, the package was having the initial velocity because this is going up. So I'm basically asking you to use the equation from this point to this point. When it started from this point going in upward direction, at that point, it will have initial velocity 0. But at this point, how much it is velocity? So that velocity will become initial velocity for the next interval. So if you use the equation from this point to this point, when basically balloon started going up, at that point of time, initial velocity is 0 from this interval to this interval. When balloon released the package, at that point of time, it will have some velocity. So from this interval to this interval, that is the final velocity. But if we talk about from this interval to this interval, from releasing package to falling down, in that case, that we will consider as the initial velocity. How we are supposed to find that? We'll simply use this V is equal to U plus AT. I hope you are able to understand this one. Come on, man. Okay. Everything is clear. And one more important thing. This has to be over here acceleration A. Why has to be acceleration A? Because this is going with the A acceleration in the upward direction. Fine. Started from rest. That's why initial velocity is 0. Acceleration A going in upward direction. And we say this T square, T naught square is the time when it was about to release that. Okay. Okay. Now, can you tell me over here how much is the velocity? Okay, that's very nice if this is crystal clear to everybody. Now, can you tell me how much is the initial final velocity at this point when we use the equation from this point to this point? You will simply say we can use this equation. Final velocity we need to find initially when the balloon started going up, means when the package started going up. Initially that was 0. And how much is this acceleration at that point of time? Can I say acceleration is the same as acceleration of this balloon, because this was attached to this balloon at that point of time? So this is nothing but this will be plus and it will be A. And what is the time from this point to this point? When this released, at how much was the time at that point? That is T naught. So this will be nothing but T naught. So V is nothing but A T naught. This will become the initial velocity when the package is released from this point to this point. Yeah, I hope you're getting me what I'm trying to say. Listen to me very carefully. See, the package is okay over here. The balloon started going up. Okay. It started from rest. U is 0 for a package as well as for balloon, both. When it reaches this point over here, the package has been released. Okay. So this is the ground. From this point to this point, what is the initial velocity? You will say initial velocity when it is released, that is the initial velocity for this interval. But for this interval, from this point to this point, when balloon is going up, initial velocity is this, final velocity is this for this interval. For this interval, this is initial velocity. Isse zyada I don't have that experience to explain this concept. Okay, so this becomes the initial velocity. Now you can use that equation and solve this question, that's all. Okay. Yeah, it's practical. So use the equation for that one. Can I say that is y2? How much is the y2? This y2 we need to find. What is the initial velocity that we got? Okay, that is s is equal to ut plus half of at square. S is equal to ut. Ut is what? That is u is nothing but this at naught. That is AT naught into T, UT into T plus 1 by 2 half of AT square. We take this as negative 1 by 2, and this will be G. And how much time it will take? Basically, I would say T square. Can I just write it? This will be Y2 is nothing but 1 by 2 GT square minus this AT naught into T. I hope I am doing it correctly, man. Okay, is it fine now? Is it fine now? Actually, my internet had disconnected, that's why. Is it fine now? Drop a thumbs up, whatever it is. Come on. You understood the last thing what I explained? Okay, this y1 basically is equal to y2. Y1 is equal to y2 over here. We got the value of y1 and y2. We equated them. We got this equation, quadratic equation in terms of t. Now I want you people to solve this quadratic equation, and the answer has to be this. Okay, so you will get this answer. This is basically the time. This is basically the time. Okay. Yes, we will finish, not within December, next 3 months, 11th and 12th as well. Chill scenes. Siva Ganesh, chill scenes. Okay. So done. Done and dusted. Okay. Are we done now? Everything fine? Chill. And this is the question that I'll be showing you in the special class. Chill scenes. Don't worry about this. All right, people. All right, people. So this is how you can basically enter our special class. That is, you need to log in, sign up with your phone number, and afterwards you can search my name over there. It will be Yawar Manzoor, and you can check it, my profile over there. Click on see all, and this is, you'll see the profile and use the code and you'll enter it. Now this is the Spark batch we have recently launched on Unacademy. You can definitely enroll in this batch in order to boost your rank in your upcoming JEE Mains and Advanced 2023. So this will start from, this has already started from 18th of August. Okay. And before leaving this class, I want everybody of you to like this session, okay? That is mandatory, okay? Fine. And this Shine batch, this is for JEE 2022 people. You can definitely go for this as well, because country's top educators are teaching you over here. So these are some of the benefits of Plus subscription. That is live classes, weekly tests, structured courses, unlimited access. Means if you take this subscription, there are so many benefits that you're gonna get in order to boost your rank in your upcoming JEE. Live classes, you will be getting weekly tests, unlimited access, structured courses. And this Iconic subscription, you'll be getting all the features you get in Plus and some of the extra benefits as well, like personal guidance, test analysis, experts guidelines, study materials, study planners. And you can use, basically, this is my username on Unacademy. You can search me over there. This is my username, and follow me on Unacademy for sure. And this is the IIT JEE subscription. If you take this for 12 months, 18 months, and 24 months, you'll be getting branded notes that will be delivered to your doorstep. If you take this Plus subscription for 12 months, 2 months of extension, and on 24 months also. Now comes basically this. If you take this subscription for 3 months, 6 months, 12 months, 18 months, 24 months. The prices are listed over here for 18 months, 12 months, 18 months, and 24 months. You can use my code in order to get the maximum possible discount. My code in order to get maximum possible discount. This one. And there are EMI options available as well. You can pay it monthly also. So this is for Iconic subscription, Iconic. The prices are listed over here. This is my code. Use it and get the maximum possible discount. This is my code. And this is the IIT JEE Mega Combat Scholarship Test. You can win up to 4 crore plus rupees. So this is on, previously it was on 22nd, now it's on 29th, and you can definitely go for this as well. And if you find any of my content as inappropriate, you can report. The link is in the description below. Thank you so much. And before leaving, I want you people to subscribe to this channel and hit the bell notification, like, share, and comment. Okay. Thank you so much. Take care. See you. Bye-bye. Yeah, I'll be sending you the hard copy on the Telegram channel. Don't worry about that. Okay. Chill scenes. Okay. Take care.